Hello, my name is Jessica Dohmen-Vereijssen. I work for Plant and Food Research in New Zealand, and our campus is on the South Island, which is the cooler region of New Zealand. And I work in the vegetable, arable and cellular entomology team. But because I work on the potato psyllid, I work a lot together with the plant pathologists and with the molecular ecologists. What I presented on today was the trapping of the potato psyllids on the South Island of New Zealand. I talked about how we wanted to know when we can trap the first psyllids in the season in the potato crops. And we also wanted to know more about the seasonal phenology of the psyllid, so we know where it goes and where it hides, and how when we see the eggs and the nymphs and the adults in the season. It was all part of a 3-year program where we did countrywide monitoring in all kinds of crops, because besides having psyllids on potatoes, we have them on outdoor tomatoes, on indoor capsicum, and also on tamarillo, which is a fruit that grows in a tree, and the psyllid actually kills the tree. But for this presentation, I'm mainly focused on potatoes. What we did was we had 2 fields in Lincoln, in the South Island of New Zealand, and we put out some sticky traps, yellow sticky traps, to catch the psyllids, and these traps were at the edge of the field. And in those fields we also looked at some plant assessments, where we also assessed the number of eggs and nymphs that were present on those plants. And we did that in 3 years, and there's a high annual variability that we can see, and we did some analyses, and it seems that the weather in spring is actually kind of predicting what you can see later in the season. And especially late spring, early summer, if you look at the degree days, so that's when degree days is kind of in between the lower and the upper threshold when the insect can develop. If you look at those degree days late in the spring, early spring, you can actually kind of see what your population is going to do in early summer. However, if it's going to rain a lot, that's what we discovered, then that has a really negative impact on the psyllids. When we looked at the plant assessments, what we could see was that most of the psyllids, the adults, the eggs and the nymphs, were on the edge of the field instead of within the field. And there was a bit of a correlation between the sticky traps and the plant assessment for the adults. They correlated quite well at the edge of the field, so that was kind of good. So what we see on the sticky trap kind of correlates to what we can find in the field. But there is just, the weather is just very determining what's going on with the psyllid population. Looking at the phenology, the conclusions are that we have a high annual variability and high regional variability. There is a lot of mortality from going from the egg stage through to the adult stage. You can really see that we lose a lot of those, maybe through natural causes, but also because of course, predation by natural enemies, and by, of course, spraying insecticides. And we don't really, we answered a few questions about the phenology, but the problem is that basically the psyllids are around all year. They're active all year, and our main questions and our ongoing research now focus on where do the psyllids go, what are the alternate host plants. We have 2 host plants that are highly suspicious. Why do they and when do they decide to go from the alternate host plants onto the potato crop? So these are the questions that we still want to answer, and hopefully that will result in developing a model that can be used by growers, be it a predictive model, when do the first psyllid arrive in their potato crop, or more like a model that they can use within the season, where they can see how many psyllids they were going to get, like what will the population density be. So I think that's enough for a few more years of research. Yeah, thank you.